Okay, so we're back again with section 6.4. We lost the first slide of the video. Hopefully we'll be able to retrieve it. But let's go ahead and discuss symmetry here for polar graphs. And the first one that we have here is symmetry with respect to the x-axis. And what I was telling the class is that when we talk about functions, we're not really concerned about those types of that type of symmetry, right? Because why?
It's not a function.
It's not a function, right? So if you have something like that and you do the vertical line test, you know it's not a function. So we don't really look for it. In fact, we hope we don't have it, right? But with polar graphs, we could have symmetry with respect to the x-axis. However, when we're talking about the polar coordinate system, we refer to the x-axis as the polar axis. All right, remember that. So we're going to refer to it as symmetry with respect to the polar axis. Now for that one, what you will have to do is replace theta with the negative theta. And if you end up with the same equation, and we're going to do some examples in a minute, then you will say, yes, it has symmetry with respect to the polar axis. Okay? The second type of symmetry here, it is with respect to that line that I was telling you, pi over 2. This line. And so what we do is that we are going to replace both r and theta with their opposites, meaning negative r and negative theta. Okay? And so if we end up with the same exact equation, then we say, okay, yeah, this has symmetry with respect to that line. And yesterday or the other day when I was going over the notes, it took me like a few seconds to understand why you have to replace both with a negative. Can you guys tell me why? Any of you? It kind of looks like it, right? But it's on the but it's on the second quadrant. So when we make the r negative, what happens? It sends the point to what? Where?
Yeah.
The other side, right? So I thought of this, and it was, okay, so if I make theta negative, follow this point, okay? So we start here, and so following the polar axis, starting from the polar axis, but we go in the negative direction, so we go from here to here, that's negative theta. And then if we were to plot positive r, the point will be here. But we want it to be here. So then that's why, well, not specifically here, maybe here. The point will be here, exactly. I'll take it back. So we start here, we go negative theta, the point is here. And the reason you make your r negative is so that the point can end up here on the other side. So that, and then here you can see the symmetry with respect to this line, right? Okay. Now the third type of symmetry is going to be replacing with symmetry what we will call with respect to the origin. And just so you remember, a very famous function that has symmetry with respect to the origin is the x to the third power. For example, a point here, 2, 8, over here, it will be negative 2, negative 8. So just so you know what it means, symmetry with respect to the origin, okay? So for that one, you only replace r with negative r. I thought it was kind of interesting, but it made a lot of sense because there's no point with replacing theta, right? You're talking about the same degrees, and then you want it to be in the opposite direction. So that's why you just changed r. So let's get to the example. And in this case, we're going to get the values with the calculator, but let's check for symmetry by hand. And so the first symmetry was with respect to the polar axis. We'll get those numbers in a minute, okay? So symmetry with respect to polar axis. remember, like the x-axis. We were talking about the xy plane. So we have the function is r equals to 1 minus cosine theta. And according to the instructions, you are supposed to replace theta with negative theta. And so if I do that, I will have r is equal to 1 minus the cosine of negative theta. And we know that cosine is an even function, correct? We all know that?
Yes.
So what does that mean?
That the theta is going to become positive.
That is the same if theta is positive, right? Okay. In case you are wondering what that means, cosine is even, so I can say that cosine of theta is the same as cosine of negative theta. That's what it means. So what we did was replace this part with cosine theta. And so now you guys see that we have the exact same equation, right? So yes, it does have symmetry with respect to the polar axis. Now let's go ahead and check for symmetry with respect to the line theta equals pi over 2. And so in this case, we're going to replace r and theta. We're going to replace them with negative r and negative theta. And so the equation is r equals 1 minus cosine of theta. So if I replace that, it will be negative r and negative theta. Here we know cosine is even, so that will be the same as the negative cosine of positive theta. But here we want to solve for r, so if I multiply the whole equation by negative 1 to make r positive, I will end up with positive r is equal to negative 1 plus cosine of theta. And so it's pretty obvious that the equation is not the same as the original. So then this one has no symmetry with respect to the line pi over 2. Okay, let's check for the third symmetry. And that one is symmetry with respect to the pole or the origin. And so for that one, all we need to do is make r equal, not equal, but substitute r with negative r. And by doing that, it's pretty obvious that if we're just changing negative r with negative r, it's not going to work, right? So if I change every term to its opposite sign, it will be negative 1 plus cosine theta. And so there's no symmetry with respect to the pole or the origin. Now, let's go to the calculator. Hopefully we don't lose the video this time. Let's see. Oh, and you guys were not, was anyone able to connect? Anyone?
I don't know.
Just give it another try if any of you were able to. If not, I'll graph it myself.
Yeah, it just doesn't highlight the login button, so you can't click it.
But you can connect to the network, just not the login. So it's because they are charged, but not fully charged. Yeah. That's weird because they were charging all lunch, during lunch, in 5th and 6th. No, 5th period was using them. Yeah, so it was just 6th. Yeah, this is an issue. Okay, so I will graph it for you guys. That's not a problem. So let's go ahead and we'll press tab. And I'm going to graph it as the second function, and then I'm going to show you a way to get rid of that first one. So I'm going to go ahead and type in 1 minus the cosine of theta. Remember, theta is here, pi button. Okay, and so enter. And you guys see how the other graph is kind of like on my way, so I don't like that. And so I'm going to press tab, And then I'm going with my mouse pad, I'm going to scroll here under list, that icon there, right there. Little. There you go. And so one thing you could do here is like you can select your first graph, and then you could uncheck it, and then it will be gone. Okay, so then we have that one, and let's try to zoom in a little bit. So I want you to notice something. So you could go to menu, window zoom. You can just zoom in, or you could change your window settings. Oh, great. I'm going to go back to standard. Oh, I get it. Because that was or yeah, you guys notice? Kind of looks like a heart.
Want to do standard or just share?
Do you guys know how to do undo? Control Z. Yeah, do you guys get the same graph? Okay. Now, we could also go and try to get the table. So if we go to Control T, and well, this function's still here, so I just want to look at this function. You should be able to maybe make that column disappear. Okay, so anyways, we do have some specific x values that don't match the ones here, right? That's not what we're looking for. But there's a way we could find them. So we could go to menu while you're on the table section, go to menu, and then go to table. And then we're going to go to edit table settings. And what we're going to do here, let's change this to, let's make our step go pi over 6. So you could use the pi button and then divide it by 6. So that means that our scale for the angles will be pi over 6. Now, let's go ahead and go to the independent. And we're going to change that to F. Let's go to OK. So let's go ahead and enter our first value, that's 0 for theta. And press enter. So you could see that the R value will be 0. And remember, we're looking at this function here. Okay, then we can ask the next value, and that will be pi over 6. So you could select your pi key, and then divide it by 6. Enter. And then you could get, oh, that is not what I had. What number do you guys get? Do you guys get the same number?
Yeah.
Okay, so I am sensing there is a problem. Are we in radians?
I get a different number.
What do you get, Adriana?
You get 0.4. What do you get?
I had 0.13.
No.
Let's see if we get the one with pi over 2, because that one's easy to calculate by hand, right? What is cosine of pi over 2? 0. So 1 minus 0 is?
What did you get? You got 0.13?
0.13, yeah.
Yeah, that's what I forgot.
That's what you got?
Yeah.
Okay. Could it be that our calculator is not in radians?
Maybe. No. Yeah.
I don't know. Maybe where I messed up was here, changing the scale. Is it time?
Yes.
Oh. All right. So go ahead and stop it. Log off your calculators, return them to the thing, And then we will just go finish the thing on Wednesday. And so what we will do instead, we'll just do the other activity. It's better. Yeah, you could turn it off and just take it off. It's fine. You don't have to like do anything special. No. Yeah, I do. But I think we are just gonna get it because I'm not gonna go. I'm gonna be here doing the TSI. So I might not be able to. Yeah. So.
Did you guys finish all the pizza?
Yeah, like the 8th period kids, they took advantage of it. Okay. So go before you guys get in trouble. Oh my God, I'm still recording. It's weird, huh?